Thank you all for joining us today for our webinar on API security. My name is Courtney and I run product marketing here at Intruder. I'm going to kick off this session with a snapshot about what we're going to cover. Today, we are going to look at the 3 basic failings in API security that cause breaches. And he's also going to take us through 6 API tips to be as secure as possible. Joel is going to take us through some of the different approaches to API scanning and how we do it at Intruder. And then we'll go through some questions at the end. Throughout the webinar, you can drop questions into the live Q&A section at the bottom of your Zoom console. If we don't get the chance to answer any of them, or all of them, or your question specifically, we will follow up with you directly after the webinar. We'll also be sharing a recording of the webinar, so take a look in your inbox shortly after the presentation for that as well. Before I hand you over to the team, let me introduce the speakers. First, we have our head of product, Andy Hornegold. And secondly, we have Joe Haig, our senior technical support specialist. Some of you have probably met Joe before, as he is at the other end of the support chatbot. So Andy, without further ado, I will hand it over to you.
Thanks, Courtney. Hey everybody, my name's Andy. I'm the product lead at Intruder. I'll just give you a very brief bit of a background about me. So I'm the product lead at Intruder. What that means is I'm here to try and make Intruder as awesome as possible for all of our customers and try and solve as many of their problems in as effective a way as possible. My background is very much cybersecurity. So prior to Intruder, I was the EU Red Team lead at Mandiant, and then before that I was the regional assurance lead at Context Information Security. And yeah, I'm trying to bring all of that domain knowledge into Intruder and help you solve problems in the cybersecurity space. Going to speak a little bit today about API security. So we'll start off with basically what are APIs. APIs are everywhere. We're seeing adoption for APIs increase massively across the board. We're seeing that happen because we live in a world where we're driving for greater efficiency, we're driving for greater automation, and as we try and drive for those 2 things, we start to see greater integration between systems. So you may, not even realize it. I'm sure many of the people on the call today do, but they really are everywhere, and they underpin pretty much everything we do day to day on the internet or on our mobile apps. So some of the things that you can see on the screen in front of you, you've got your cloud providers. All of them have APIs. A lot of what they do under the hood relies on those APIs communicating with each other. Stripe, payment providers, Datadog for your management of logging and tracking and analytics. Other things like WhatsApp and your compliance management as well, like Drata. We use Drata at Intruder, really cool product for trying to automate your compliance for like SOC 2 and ISO 27001. Intruder also, we have our own API. So if you want to try and automate further your vulnerability management process, then take a look at Intruder's API as well. One of the ones you can see on the board there in bang in the middle at the top is Twilio. Twilio are now they are a huge organization. They're worth about at the end of last year, I think it was $3.8 billion in revenue. And we're starting to see APIs introduce or be introduced into I suppose environments that historically haven't really had APIs. So one of the things that we're seeing is, I suppose, telco providers. Telco providers historically have large legacy estates. They were some of the original, obviously, pioneers for networking. So they have a whole lot of functionality and a whole lot of networks that have this legacy functionality. But we have a whole bunch of people who are progressing through their careers these days that are very heavily tied in with, I suppose, dealing with HTTP and dealing with more common protocols. They don't really want to dig too deep into the full S7 network and how that's bolted together. So we're seeing telcos try and jump on the bandwagon and eat some of the pie kind of that Twilio has had success with when it comes to making SMS accessible or sending SMS over HTTP APIs. And we're seeing these APIs and telcos. This is an article article from Tech Informed. APIs and telcos like a holy union. I don't know if anybody out there is aware of Betteridge's law of headlines, but the law says pretty much if the headline is a question, the answer is almost certainly no to that question. So a holy union, it's still yet to be seen. The reason I say that is because, yes, even though APIs allow us to work faster and allow us to do things and integrate faster and get data from one point to another, it also allows the bad guys to do things much more effectively and much more quickly. So what we're seeing is much more rapid automation of attacks against APIs. We're seeing a lot of people start to suffer breaches as a result of APIs that are exposed to the internet. And there was recently a poll carried out by Postman. So Postman is the API tool that a lot of people use to engage with APIs while they're doing development. It's very widely used. They polled 37,000 devs, and 48% of those 37,000 said that they have suffered a security breach at least once every year. And that number is crazy high. And then 11% have said they have experienced one security incident more than once a week, which is scarily high. I'm going to walk you through a few organizations and a few headlines that we've seen over the last kind of 2 years. And all of these have been breaches or disclosures that have been a result of API weaknesses. Some of the headlines or some of the logos, one of the logos, the very first one, I suppose, is technically out of date now. I suppose it should be an X rather than a bird. But all of these organizations are pretty large orgs. They have relatively robust security frameworks. They have people in charge of security. And I imagine not everybody on this call has like a dedicated security team. So I think as we go through this, it's worth bearing in mind that, yes, API security is something that we need to be aware of, but not everybody is doing it well. And even some of the big guys who have a lot of money to spend on security are having issues trying to cover and handle these relatively basic security issues that they're running into. So I'm going to start off with Twitter. People probably saw this over the last, last couple of years. There was a whole bunch of headlines that came out about Twitter's users' data being exposed. You saw all kinds of numbers, 200 million user emails, 400 million in some places, like millions and millions of users of data being compromised. A lot of the headlines you can see are like a gold mine for PII and social engineering. They absolutely are. Some of the data that was exposed can be used for, I suppose, correlating who a Twitter user is, like behind the scenes. If you're interested, I suppose, in online privacy and you don't use your main name or your full name on social media, these kinds of leaks can lead to that information essentially being sussed out. So if you use your email address, which has your username or has your full name in it, then people can start to de-anonymize social media users. But we saw lots and lots of posts. One of the main ones that came out, this was the initial one back in December 2022. So a data breach, 400 million users. This was posted on breach forums, and we saw quite a lot of news around it. We then saw a second post. This was July, earlier in 2022. Again, this number here we're seeing is about 5 million users, which is, again, a reasonably high number. You can see that they say they've actually, the people impacted are celebrities, companies, and then other random people as well. Data collected includes email, phone numbers to all of those accounts. And then we have one that happened beginning of January 2023, another post mentioning 200 million users. They call it a database/scrape. And you can see the kind of information that was posted. This was just a sample that was provided by this post. And it was a RAR file that contained all kinds of details like name, screen name, followers, when the account was created. So it's pretty serious information that's being leaked. When these leaks started to happen, we saw a post from Twitter saying that, we had no evidence to suggest that someone had taken advantage of this vulnerability, but the vulnerability itself was from an update in their code in June 2021. So there was about a year of time there where potentially that bug was being exploited and information was being harvested. What the bug was, that all of these leaks were actually just one vulnerability within a specific API within Twitter's infrastructure. So for those of you that use Twitter, you may have seen this kind of setting within your Twitter app on the iPhone. You can let others find you by email, you can let others find you by phone number. Under the hood, that functionality is all API based. So if I want to find Joe, for example, and I know his phone number, I can enter his phone number and then retrieve information about his account. Essentially, what's his username, how many followers does he have, all of that sort of info. But somebody was able to take advantage of a couple of bugs in that API, and it's all publicly available on HackerOne. So this bug was originally reported via HackerOne. What you can see is the researcher found that on this screenshot, the first request is essentially just going through the process of getting a token that allows me to carry out further requests on the API. So you can see the request at the top and the body that gets returned. I then take part of that response and I feed it into my next request. So this is a very simple request that I capture, and then I replay this request again and again and again and again. What happens is I essentially enter a phone number. That phone number or that ID, a phone number, if we're doing scraping, I can just send phone number 1. I can then increment the number by 1 and then keep sending requests one after another. And try and retrieve all of the user IDs associated with those phone numbers. What these people did was they carried out that attack. They essentially enumerated a whole bunch of users. They got this user ID that you can see, which is the sanitized field at the very bottom of this final image. And then I can just request using that user ID. I can send a request and I can get all of the information associated with that account, which includes their email address, their full name, their number of followers, when their account was created, and a bunch of other information. So some of the key basic vulnerability issues that we're seeing here are essentially enumeration and scraping, and potentially an authorization weakness as well. So the idea of enumeration and scraping is that I can send thousands, tens of thousands of requests very quickly to try and hoover up as much data as possible. And the authorization weakness really is, should I, as an unauthenticated user, really be able to retrieve this information at all? So 2 potential weaknesses there. Second breach that I'm going to run through is Optus. I'm going to assume that everybody heard about the Optus breach back at the tail end of 2022. It was huge. It impacted 30% of the Australian population, and it included data that essentially could allow people to potentially try and take out credit or impact health, their essentially the Australian alternative to the UK's NHS. It hit headlines everywhere. It hit headlines in the BBC in the UK, ABC in Australia, and it was I suppose a firestorm that happened over a significant period of time as well. What happened was there was an initial post on breach forums, which was Optus. Somebody said they had a whole lot of information based on Optus customers. And you can see some of the numbers in this post, like over 4 million of them have a form of identity document or number. That can be driving license, it can be passport, it could be any other like important document associated. There's driving license numbers in there, like the active subscriptions that those users or those customers of Optus had at that point in time. So it's a pretty huge amount of information that could be called up. One of the interesting things is the request for the amount of money that this person was asking for. So they were asking for like $1 million US, and that's it, like $1 million US for that amount of data from the largest telco provider in all of Australia, or the second largest. It's a pretty major breach, and they're only asking for, realistically, when you see some of the other breaches, the cost associated with those, doesn't seem like that much money. And there was quite a lot of conjecture at the time of how experienced really is this threat actor? Like, have they really only asked for $1 million? Why have they only asked for $1 million? Is it because potentially they're not as well versed in I suppose extorting information or extorting money from these people? So, you know, $1 million like sounds great. Optus responded. So this was Kelly Bayer Rosemary, and she mentioned that essentially they have, like, Optus tries to have or does have very strong cyber defenses, and that there's really sophisticated criminals out there that people need to be aware of. That was quite a strong like message response. It's one that we see quite a lot. Like, it was a sophisticated attack. We saw a very sophisticated threat actor. A reporter went out and started to engage with the person who had leaked this data and started to ask questions. Essentially, how did you go about getting this information? So these are the responses from the attacker. So Jeremy Kirk asked, like, hey, how did you do it? And the person leaking the data said, here's the URL. You can see it starts with API. Optus took the domain offline. Great, like, pretty standard response if you see something being going wrong. It was a regular API that customers use to gather their own data, but it had an access control bug. It's like, cool, okay, what is this access control bug? So Jeremy asked, and the response was, well, there was no authentication needed. Like, it's bad access controls. It was open to the whole internet for anybody to use. Okay, that's not ideal. But how did you go and grab so much information? And the response was, well, we actually just enumerated a single contact ID. So similar to the Twitter breach that I mentioned before, where you have one field that has an ID in it, you just iterate that number from 1 to 2 to 3, and you go through that list and you just hoover up all of the responses you can. It was the same kind of compromise that the attacker is alleging they carried out against Optus. In this case, they went between, they used the contact ID from 1 to 8 million, and then 40 million to 48 million, and they received a whole bunch of hits off of that. So when you think about that, we use the word sophisticated quite a lot in cybersecurity, but, you know, this was the cybersecurity SAR in Australia, went on to ABC and had this conversation. The response was kind of scathing of Optus, which, you know, it's a difficult situation for any CISO to be in. What happened here was, like, it's quite a basic hack that was undertaken, and we shouldn't have telco providers in this country leaving the door open. And the ABC presenter asked, so you don't seem to be buying the line that it was sophisticated, to which the response was, well, it wasn't, so no. I mean, I think in massive organizations, you know, people make mistakes, these sorts of things happen. And I in no way want this to be seen as pointing fingers, because it isn't like Optus were the victim here. They were not. They were the victim. This is a very difficult situation, and if people are building APIs and these kinds of problems are still emerging, we need to be able to find these before they go live or after they've gone live, but before attackers do. Just a little bit of a background. Jeremy Kirk mentioned that this was all hosted in, like, Optus's API was hosted in Google Cloud / Apogee. And when they started hitting that API, the attacker, they saw a big spike in traffic. So there was some monitoring which detected this, and it was that spike in traffic that triggered something's not right here, we should try and respond. Monitoring is super important, and like monitoring of what's happening, but also monitoring for instant response as well. But in this case, if you're monitoring for stuff leaving the network, by the point you detect something having gone wrong, it's already left your network. There's two final ones that I want to touch on. These are much more, I suppose, more smaller. We have less detail on them. One is Odin Intelligence. Odin Intelligence are an organization that build technologies for law enforcement. One such technology was an app called Sweep Wizard, which is a policing app. And the idea of Sweep Wizard is that it allows law enforcement officers to coordinate with each other when they're going active raids or arrests. So what the app looks like is a little bit like this. You can see that there's data like the officers' names that are currently included in the operation, who the targets are, and then also like where those targets are located, GPS coordinates. There was a breach that occurred this was raised to Wired, so it's hard to really call it a breach. Wired were contacted anonymously or were contacted by a security researcher saying, hey, there's a problem with this technology, I think you should investigate it. And then Wired went away and did investigate. Wired downloaded the Android version of the app, reversed it, found all of the API endpoints, and then started sending requests to those API endpoints. And what they found was that actually the API endpoints didn't require any authentication. Similar to what we saw previously with Optus, authentication being a big problem. Odin responded by saying they take security very seriously, but they were unable to reproduce the alleged security compromise. You know, sometimes these things are difficult. If you're a small company and you're trying to respond to these kinds of events, it can be difficult to do. I think I just want to highlight on this one that when we're talking about the data that can be compromised, we've talked about PII with Twitter, we've talked about national insurance and national identification information with Optus. With Odin Intelligence, we're talking like live location of people who are actively trying to potentially arrest you. So one of the things is if there is a bad threat actor or a bad actor who is monitoring this, happens to have found this, the best outcome is they manage to evade law enforcement by running away from where the officers are. The worst is, could be significantly worse. Finally, the T-Mobile breach. This was a little bit of a weird one. This happened at the beginning of this year again, and 37 million accounts impacted. One of the big ones, or the big differences about this was actually we didn't find out about it from the news. We didn't find out about it from them, I suppose, publicly announcing it in any way. This came through an SEC filing, which was like the T-Mobile's 8K SEC filing. And an 8K filing is basically publicizing or telling the SEC about an event that's happened which might impact their the company's value or their price. So again, what we see here is an API without authorization. We don't know what authorization means in this case. For those of you, I'm sure many of you do know, but like authentication is me telling you how much, like who I am, and you validating that I am who I am. Authorization is more, you know who I am, but do I have the rights to access the information or the functionality that I'm trying to access? In this case, we're not really sure whether it's authorization or authentication. The reason I make that distinction is because if it's an authentication weakness, potentially anybody on the internet could access this data. If it's an authorization weakness, there's the potential that actually it's only kind of active customers or somebody who has some kind of account that could access this information. Another noticeable thing is that the filing happened on January 19th, but the impacted API the attack started on November 25th. So there's a pretty big window there where this exploit or this attack was happening. That's a bit of a background about like what are the problems, like what are the big issues that people are having when it comes to APIs that we're seeing in the headlines. And you can see that already there's some relatively basic problems that we need to try and tackle. So what can we do to avoid API breaches? Let's start with the basics. Visibility is a really good start. So we did some research ourselves across 3,000 organizations. We checked what assets were under management for simple vulnerability management and monitoring. And we found that actually only 21% of internet-facing assets are monitored by some kind of vulnerability management and falling into that vulnerability management process, which means there's 79% which are not. When it comes to organizations like Optus, that's quite a big area where potentially there's assets which aren't being scanned and identified. So really visibility, if you're going to go and try and avoid any of these problems that we're seeing, first step is, where are my APIs? Like where can I find them? How do I start to get them included in my vulnerability management process? Second one is like, don't rely on a single solution. Like, yes, you can do vulnerability scanning, but that's not the be all and end all. The same with relying on a single API gateway or management solution. That's not necessarily going to secure you against all of your threats. You need to start to maintain defense in depth. So we're talking potentially putting defenses in front of your API, if that be a web application firewall or an API firewall, and then doing vulnerability scanning, but also bringing that security process much earlier in the development lifecycle. So not just once it's live, but also earlier on when you're going through your development cycle. Everybody, I'm sure, is well aware of the earlier we start to find those vulnerabilities, the more cheap and more effective the fixes are. Perfect is the enemy of good. I'm not saying you shouldn't aim for perfect. Everybody can aim for perfect. That is great. It's nice to have ambitious goals, but don't let that prevent you from starting now. If you're an organization that doesn't have any kind of API security, start small and scale up. And as you mature, you'll start to build in the additional layers of security that you need. Maintaining that holistic view as well is really important. So API is just one layer of your whole environment of the data and the functionality that API allows access to. So the data the Optus Breach allowed access to was stored somewhere on a database, on a backend system. The API is only one narrow gateway to that data. There are other elements. So the rest of that system that hosted the API, are there open administrative services? If there are, can I log into that backend? Can I pivot through other vulnerabilities or other doorways? Can I compromise other systems to get across to that data? We can't just look at the API layer in isolation. If we do that, we start to miss the bigger picture and potentially miss other avenues of attack. Final two, one of my, I suppose, the most important ones when it comes to Intruder is document everything. API documentation is super important. APIs are very opaque. They're opaque because unlike web applications, they don't have a UI where you can go and browse and you can start to understand and see where all of the nooks and crannies are within the application. Instead, an API you send a request to an API and you get a response. You don't know whether that API request was correct or not. How do you know if you found all of the potential requests that the API accepts unless this documentation exists? There's a lot of functionality out there and tools out there at the moment to allow you to automatically document APIs, but this really will feed into the vulnerability management and vulnerability scanning process. And the goalposts are always moving. So doing a once-in-time vulnerability scan and management or check of your APIs is great, but your environment changes, your APIs change, APIs scale up over time. You introduce new APIs, new vulnerabilities emerge in the frameworks that you're potentially using. So you can't just do a one-off scan. It needs to be continuous, and breeding that into your vulnerability management and your API security program from the very beginning is important to bear in mind. So the three basic failings that we've really seen over the last, those 4 breaches that I talked through: the lack of authentication, allowing anyone to access everything; lack of authorization, allowing one user to extract information from other accounts and get access to functionality they shouldn't be able to access; and a lack of monitoring. So if you don't detect scraping or what's the data that's being extracted, then how can you know that an event's even occurred? My big tips, the 6 that are there, we've got visibility, maintain that defense in depth. Perfect is the enemy of good, so get started now. It doesn't need to be difficult. Look at the big picture, document all the things, and make sure it's continuous. That does seem like a lot. There is quite a lot to take on board there. And I've mentioned already the big guys are struggling with this. So how can we make this easy for you? And with that, I'm going to hand over to Joe, who will show you how we help at Intruder.
Thank you so much, Andy. It's a really interesting stuff there and some great tips. Intruder is an awesome way of ticking off lots of them boxes of Andy's tips. So the first one he mentioned was about the visibility part of things. So one of the ways in which we make that really simple is on our network view page. You can view all of the targets that you've added to the portal. Bearing in mind, these targets can be automatically pulled in as well if they're cloud targets and things like that. So there's lots of ways of making sure you've got that visibility. And for example, I can see here I've added a couple of targets and I can see a port 80 open, which could indicate to me that there's an API running on some sort of web related functionality running on these ports. So we can then dip into that target on our targets page. And like the second one, to make it nice and easy, we can add an authentication and add an API schema to your target. So to do that in Intruder, in your target detail page, you can click into your tabs that are along the top of that page here. You'll notice there's one that says APIs. You can, at the moment, we support the upload of Open API or Swagger schemas. So you just need to click into this green button to add the schema, click that top option. And again, we make this process, like I mentioned, really simple. So I'm just going to call this my schema. I'm going to upload the file onto that. And then I'm just going to pop this base URL in here. And then you can then see this has then been successfully added and uploaded to this target. From here, you can then choose to run an authenticated scan, which I hope we're all doing, or a not unauthenticated scan if it is not authenticated. You can do that by pressing this green add authentication button, either selecting one that's already added to the target, if this is a web application, or adding a brand new one and following the steps as you would to add an authentication normally. For this one, I'm going to select this authentication that's already been added, click save. And then from here, you can just kick off a fresh scan on this target. And I put test API scan. And then this is going to start off a scan. The important thing to note about this scan is, as Andy mentioned, we want to look at everything, the big picture related to this target. There's 3 parts of this scan that will run. You'll have your base infrastructural checks, so things you want to know about regarding that particular target and the service that's hosting it, so the actual machine itself that's hosting this API. So you've got things like maybe vulnerable software version, things that might be out of date. But you've also got 2 additional levels here. So if it's a web application, you've got then web application checks that are being run. So that makes that awesome in-depth view of maybe a custom application that has some functionality that's not default in any way. And you've also got the API scan. So we're checking your API endpoints and everything like that that you've uploaded and referenced in your schema file. So you can be sure you've got full coverage of those API endpoints if they're included in that schema. And you know that we're locating them and scanning them in a comprehensive way. It's also a good thing that you mentioned about documenting all of your schemas and stuff like that. So one way to do that is obviously you've uploaded this schema here. So you're making sure you have a regular cadence of uploading that and make sure when you update that, you update it on the portal, that sort of thing. And the final thing I wanted to highlight is he mentioned about monitoring as well. So being able to make sure that you're monitoring constantly or consistently this specific target is something that's really important. And we can actually do that with a scheduled scan. So to do that in Intruder, I head across to the scans page, click the green schedule scan button, and then you can add in here, I'm going to put in this API demo. Then I can pop a particular date. Maybe I want it to run every single month on the 10th. We're then going to select a time, maybe one that's maybe not the API itself is not going to be used as much or something like that. Pop that in there, and then we can pop a name in there for that. This then means that you have a monthly scan every single month. Whenever any changes are made to the infrastructure or anything like that, this will be automatically scanned every single time that happens. The other thing I wanted to highlight is in order for this to be scanned, you need an application license, which is something that you can view from your targets and licenses page. You can view more information about them by the help article that's here, or also adding authentications and schemas. You have a nice, quick, easy way of accessing that there. Once that scan is complete, any issues that have been detected on your target will come across into your issues page here. Again, you can filter this here by your specific target. So I'm going to put API demo there. And then you can see that this one has not yet completed, so no scan issues have been found. And you'll also notice at the top of this page, you've got 3 advisories that have been flagged. This is something for premium and Vanguard customers. It enables our security team to do some manual investigation work and some bug hunting. So that might be something that might be of interest to you as well. I hope that quick demo helped you guys. I'm going to pass back across to the guys and see if you've got any questions.
Thanks, Joe. Really great summary of how you scan APIs with Intruder. Let's jump right into Q&A, as we've got only time for a couple of questions. First up is Andy. What else can we do to make sure our APIs are secure before going live?
Before going live, so I mentioned previously that kind of shifting left. So there's a bunch of other ways that you can start to secure your APIs. If you're building them yourselves, if you're going through that process, you have a dev team writing APIs, then making sure that security is considered as early as possible. It's a drum that I'm sure everybody has heard bang repeatedly. There's tools out there that can do static code analysis, so they can do linting and live tracking. So this is built into like the integrated development environments, IDEs that developers use as they're carrying out or doing their development process and writing their code themselves. It can start to detect weaknesses that are coming in during that process. That's really good for kind of live feedback for relatively quick and easy bugs that might arise. You can then carry out, I suppose, at the next stage, once that code has been written and you're going through your commits to your central code repositories. If you're using like a Git repo or an SVN, you can then do on commit checks, or when you start to do pull requests or merge requests, you can start to carry out checks. So doing unit testing specifically for security requirements. So if you have hard security requirements, like this API endpoint should not be accessible from with a request that has no authentication header, for example, you can start to build those checks in yourself. That obviously requires you to understand what security checks you need to be looking out for. And it's kind of hard to have I suppose, a complete list, but you can start to introduce that kind of assessment. There's other tools out there as well that help with this. So they can do static code analysis and container analysis as you start to push things and build your images. If you're hosting those APIs on container services, you can do image checks. And then once you've started to actually carry out dynamic testing against these endpoints, you can then use scanners like Intruder. I'd suggest scanning when you get to like your staging or your earlier, if you have live development environments that you can point your scanners at, get them scanning dynamically as early as possible. And there's a lot to be said for static code analysis. Like, I think it's a very good tool in people's arsenal when it comes to securing APIs. but also validating what you've got in a live dynamic environment using vulnerability scanners also provides another level of security and insight that you won't get with just static analysis. So there's a whole lot that you can do there. Also consider continuous pen testing as well. If you have one of those providers, they can help you get involved earlier on too. Yeah, I think that's it from the top of my head.
Awesome. Thanks, Andy. Joel, one for you. Can I run an API scan without a schema?
So you certainly can run a scanner on a target that is hosting an API, but the type of testing that will be uninformed. So we probably want to, if you have a schema, then it's the best option is to upload that. Then we can be sure all of them endpoints are being scanned and they're being scanned in depth. There's lots of different things about different benefits of running an API scan versus a standard like infrastructure scan. Because if you don't have an API schema, you'd be running sort of a standard infrastructure scan, which would just be that first part I mentioned when I said the 3 earlier. So you're going in more depth with an informed scan. You'd be running much more in depth. You'd be making sure that any custom functionality that application has is being checked and being evaluated, which is something you perhaps wouldn't get with uninformed testing. So the short is, yes, I would recommend uploading a schema if you can, but if you can't, there's still benefits to running uninformed testing as well.
Awesome. I'm going to go to the next question, which I have a suspicion will be for Andy. Knowing a bad actor will most likely not be authenticated. Can you speak to the benefits of scanning via authenticated and not authenticated?
Yeah, so it's a really good question. If you're running an authenticated scan, you're going to get greater coverage across the entire API, because if you're uploading a schema and you're authenticating when you're carrying out that scan, every request I send is going to be authenticated, and that's great. That gives you greater coverage. You start to understand where there's potentially weaknesses within authenticated elements of the API. Running an unauthenticated scan, you start to see where the weaknesses are from I suppose from that unauthenticated perspective, obviously, but you won't be able to hit those authenticated endpoints. What you should start to see from the unauthenticated scan is you should start to see error responses from the URLs that require authentication. So running just authenticated is good for, I suppose, trying to get greater coverage across your entire API. But I don't think that you should discount unauthenticated scanning. As we start to talk through and as you start to, I suppose, extrapolate what is authentication, unauthenticated is another form, and excuse me if this sounds like weird, but it's another form of authentication. It's another authorization layer. So at the least trusted side, you have unauthenticated. Then everything above that potentially has other layers or other levels of trust. So I could have 3 types of authenticated account. I could have a regular user, I could have a supervisor user, and then I could have like a super admin user, which can do everything. Unauthenticated is just on that sliding scale. So if you have all of those different types of accounts, I still recommend doing scanning against each of those types of accounts, because doing one in isolation will give you a view from that one account. But if you want to start doing differentiation between those accounts, so like, hey, my super admin can access all of these URLs, that's great. My unauthenticated user can only access like 4 of the URLs that my super user can access. You're like, that makes sense, that's cool. Those should be the only 4 URLs that super user can hit. But if you start seeing that your unauthenticated user can hit like 250 of the 250 that your super user can hit, and there's no errors, then something's probably going wrong on your authorization model as well. So when we talk about unauthenticated scanning, informed and uninformed, there's still value to doing both in both sides. It depends on what your threat profile looks like and really what you're trying to get out of the scans. If you're going for comprehensiveness, don't just do an authenticated scan, do an unauthenticated scan as well. And you can do that in Intruder, where you saw Joe add that API and he added an authentication. just add another API, but don't add an authentication to it. That time when you kick off a scan, under the hood, we're going to run an authenticated API scan and an unauthenticated API scan. And those results will coalesce in your issues page within the Intruder portal. Hopefully that helps.
Awesome. Thanks, Andy. Well, that's all we have time for today. I know there were a lot of other questions that came in, so we will follow up with you directly. I just want to say thanks so much, Andy and Joe, for your time. And thanks everybody for joining us today. Remember, you can always get in touch with us on the chat box on the website or in portal. And if you are new to Intruder and interested in trying out the API scanner, just head over to our website and sign up for a free trial. Thanks again, and we'll see you next time.